why didn't I flinch? Because the laws of science differ fundamentally from those of...
Have you ever wondered why we have heard about a force called gravity our entire lives, and yet nobody has ever been able to prove that it exists, even though untold numbers of experiments have been performed seeking its cause? Academics have proposed many strange solutions to their mythical gravity by inventing many theories about gravitational attraction: inward pulling gravity, gravitons, gravity waves, 4D warped space and time, to name just a few. It is even claimed that gravity has a velocity, though nobody can explain what is traveling to create this invented force. Scientists do not even know how their mythical force operates, whether it is graviton particles, gravity waves, a strange, unexplainable force which acts at a distance through empty space, or a four-dimensional warped space and time delusion. We have all heard about this inward pulling force called gravity from the academic scientists, and its warped cousin conjured up by Einstein, yet no one has ever discovered the power source for its never-ending pulling force, or its ability to warp space and time perpetually throughout eternity. This theory violates the conservation of energy law, so it cannot be validated using the very foundational formulas, laws, or equations cherished by academics themselves, and requires a kind of religious faith in its existence, since it cannot be seen, proved, nor validated. Have you ever heard that astronomers believe that gravity knows, as if it has consciousness, just how much force to dole out to the various heavenly bodies according to how much mass they have? Newton added the product of two masses to Kepler's third equation without justification, which has created all of this confusion, since mass is not the cause of the effects attributed to the myth called gravity. For example, academics believe that the Sun pulls on Jupiter 300 times harder than the Earth, because these astronomers believe that Jupiter has 300 times more mass than Earth. Academic astronomers claim that the Sun pulls on all heavenly bodies in our solar system with a different amount of force according to how much mass they have. How this could happen is never explained, nor is it remotely tenable. Anyone with common sense can see this is absurd, and would reject this proposition if they knew what these so-called astronomers actually believe and have faith in as their science of gravity. Patti Spolter proved in her work that the product of two masses which Newton added to Kepler's third equation is fallacious, and that Kepler's third equation, area times acceleration, is the math that accurately describes the motions of heavenly bodies. This means that Newton's so-called universal law of gravitation, based on the product of two masses, is in fact false. Newton's formula for universal gravitation gives sums which are off by many orders of magnitude when comparing the various motions of the heavenly bodies within our solar system, unlike the uniform results created using Kepler's third equation of area times acceleration. It is claimed by academia that gravity is responsible for the formation of the Big Bang universe, which, as anyone with discernment knows, is an impossibility as well, and that without gravity, the universe would be without thermal energy and composed only of equally spaced particles. The answer has been staring academics in the face for several generations now. Electric laws were unknown to Newton in his time. However, now we know with great accuracy the effects of electricity as obeying the inverse square law. The fact is that so-called magnetism, which in reality is electricism, light, sound, and radiation are all electric motions. All motion in the universe is electric. This is why the myth called gravity conforms to the inverse square law, since it is electric force which creates the effects falsely attributed to the fictitious force called gravity. Electric force in all forms, scales, and pressures, from the elements to the galaxies, obey this foundational, inverse square law. Electricity is the only force in the universe. It will be shown that the force called gravity, which was created by Newton and later modified by Einstein and others, does not exist and is purely mythical in its creation. The consequences of this conclusion are immense. It means that a huge list of non-existent entities have been invented by academic scientists based on the mathematics of the non-existent force of gravity. For example, here are a few of the many academic science myths created from their foundational myth called gravity. Dark matter, dark energy, black holes, singularities, event horizons, WIMPs, MOND, machos, neutron stars, gravitational collapse, gravitons, gravity waves, quantum gravity, inward pulling gravity, gravitational lensing, the gravitational constant, the Schwarzschild radius, gravitational radiation, frame dragging, general relativity, anti-gravity, virtual gravitons, and quantum field theory, which are in fact false as well. With the fall of academic gravity theory, all of these other fallacious theories fall with it. No experiments are required to prove my assertions, since we have volumes of data from experiments already cataloged, which only need to be converted to the understanding that the electric force is the cause of everything in our electric universe, and not a mythical and magical gravitational force that acts at a distance, or warps space and time to control all heavenly bodies in our infinite, electric universe.
In this video, I'm sharing my deeper look at the popular video starring Brian Cox where he visits NASA's biggest vacuum chamber to allegedly demonstrate how gravity works in an environment free of air. The first thing that caught my eye when I watched this video was the editing out of a feather falling before its time. I'm not sure why they felt the need to cut that out. It didn't seem like a big deal to me. It just seemed like they just could have kept the cameras rolling and went with it. But giving them the benefit of the doubt, let's just say they wanted everything to be perfect just because. But I'm already getting a sense that this video is not straightforward. The first drop seems legit at first blush, but it's actually all chopped up. And this is the only sequence that includes the actual dropping of multiple feathers and where the lighting is actually good. Later, the multiple feather drop is gone and all the overhead lights are turned off. I wonder how many hours of shooting they had to do to make this 4-minute video, or even this 4-second clip. This is exactly what you get after the drop in the first example. First, the feathers falling in all directions, then the feathers falling back in a cluster, then that cluster magically landing in the right spot, and then the feathers are gone altogether. And all this in 4 seconds. Seems legit, right? The second example of a non-vacuum fall has several lights turned off and starts with a drop of a single feather and ball, and then the ball landing without any feathers in the shot, and then we see multiple feathers falling together to imply they haven't even come close to landing yet. But then that's all we see. We don't see the feathers landing, and we never see this whole thing without any cuts. Obviously the cut job is bad because it starts with 1 feather and ends with at least 3 feathers. If there was no deception here, why not show the whole sequence straight up, from release to landing? Do they really expect us to believe that these 3 cuts are all from a single event? Obviously they are not. Now we'll be getting into their example that supposedly takes place in a vacuum. On this slide I added a snapshot of both the alleged non-vacuum on top and the vacuum on bottom footage in order to get a side-by-side view. Notice anything fishy? To me, the vacuum footage is more grayed out and the focus isn't as good. In this non-vacuum clip in the video, you don't see the actual release and you never see the bottom of the feather. The feather to me doesn't seem to be behaving right either. Is gravity getting a little help? I don't know. Can't see. Anyway, I had a theory that the ball was edited into the feather footage later. And sure enough, when I made a few adjustments to the image in Photoshop, an apparent pixel border revealed itself. But that's not all. This video continues to insult our intelligence completely. Do they actually expect us to believe these 2 clips represent a single uniform event? They try anyway. See for yourself. How do we go from 1 feather to a group of feathers? Unless the magic of gravity has the ability to add feathers. Just like the non-vacuum footage, you never see any uncut vacuum test footage either. It's always these 3 clips you see here. You start with 1 feather, as we discussed, then it cuts to some blurry long-range shot of the feather cluster and then the ball group falling together, and then they cut again to the landing perfectly on the box. If they want close-ups and whatnot, that's fine, but at least 1 real-time continuous shot of the whole event from beginning to end should have been included. What do they've got to hide, right? And I'm not in a vacuum expert, but the feathers not tipping at least a little bit due to their variance and weight balance seems very odd to me. And don't things expand in a vacuum too? Just saying. I noticed as I watched the blurry, overexposed, long-range shot that the background around the falling bundle seemed to be getting smudgy, and you can see that for yourself. I thought this could use a Photoshop test. With just a few minor adjustments, I got this image here. It looks to me like a cut and paste job. You can try this yourself and see what you think. Just try adjusting shadows or reducing contrast, and then bring up the color saturation all the way and see what you get. This shot here is the very last frame you'll get to see in this not at all straightforward and badly cropped footage. They totally leave us hanging. They never show the final landing after the bounce. Was there more than one bounce? Does the ball land in the same spot? Do the feathers stay afloat? Do the feathers drop fast again? I mean, come on! Okay, now I need to pick on all the drama from the video. I can't leave it out completely because it does constitute half of the 4-minute video after all. Is it just me, or are Brian and the NASA guy playing it up too much? Look at the guy at the terminal. He's like, oh, that's right, I'm supposed to be excited. Even if it wasn't all garbage, his reaction is at least more of what I would expect. A simple smile and a nod of approval is all you really need here. Or maybe this reaction shot was done while these guys were looking at the actual uncut and unedited footage, where cooler things might be happening, like feathers beating the ball to the ground, or feathers exploding. You might be thinking, okay, Fran, this experiment has been done by others. Well, of course I had to check out the other footage. It wouldn't be fair to just examine the most popular and publicized video. The reason I said that maybe our actor crew was watching the feathers beat the ball to the ground was because that's exactly what I saw over and over again when I slowed down the other videos of this type of experiment. The other videos varied a lot in their presentation style, and some used tubes while others used a chamber. But in all the videos, lighter objects stay ahead of the heavier ones. This particular video was tricky to slow down because it all happens in the blink of an eye, but the feather clearly beats the ball. Again, the feather is actually ahead of the ball when you slow it down and pause. The image quality of this video isn't very good, but you can see that the feather is beating the ball on the first part of it where the whole apparatus is shown, but it's very blurry. So I didn't use that, though I didn't use those images. And I don't know why this bothers me so much, but I noticed the operator always keeps the tubes to a tilt for some reason. And in my humble opinion, these experiments fall short of proving much. The only thing they prove to me is that without air, feathers fall fast. But did we expect anything different? Air resistance is exactly what feathers are designed to do, after all. In this video, the tube is flipped twice, if I remember right, and one of those times the hammer object was actually on top of the poor feather. Sometimes I wonder if these vacuumed tubes get some kind of electrical static to them during this process. Are these tubes and parts all made from some special plastic that prevents it from collecting charge? Feathers love to stick to balloons, you know. Come on, Brainiacs, help me out here. And this is my second favorite video, before we get to the next one, which is my first favorite. But this one's my second favorite because both objects are about the same size and shape, and because it is more clear than some of the other videos. In this video, again, it seems like they are the same when viewed at regular speed, but they are not. The lighter object is ahead. In this particular video, I like that they've added a third element. None of the others I saw did this. Therefore, this is a better experiment in my book. The clarity of this video is pretty good too. However, we are only provided one example of each before and after. I would have liked to see it done repeatedly with the same objects and then done again with different objects. Even in this video, the feather is now ahead of the heavier ball in vacuum. It seems from my observations of all these videos that a vacuum chamber changes the game to such a degree that feathers actually beat their heavier companions with consistency. I don't understand why this is not addressed. Surely I'm not the only one noticing this, right? I know people often just see what they want to see, but come on people, take a deeper look. It's right there if you just pause the videos. I think the implications are amazing, but what I need are the brainiacs to wake up. Obviously, I think that the popular video is completely dishonest, but I find the other videos to be too much taken for granted. Most don't have good quality video, and most only use two objects, and none use a variety of objects, and none discuss the other scientific stuff that might be taking place, such as a shift in pressure within the vacuum, or a change in static charge due to vacuuming. Have you ever seen the peeps in a vacuum experiment? If not, check it out and ask yourself, does going from air pressure to no air pressure and then back to air pressure have an effect on the structure of other objects as well? It would seem that feathers would probably expand to some max fluffiness, right? Just more to think about when you watch these videos for yourself.
Now if you do some searches, you will find, if you look for Thomas Townsend Brown on YouTube, you will actually find some laboratory videos, and these experiments were done a long time ago, experiments into electrogravity, and people have tried to say that these effects were nothing to do with actual electromagnetic effects on gravity, but that these were purely ion wind. That is to say, the air is moved from one terminal to the other, creating lift or creating propulsion. Now, as part of these experiments, you will notice the use of a vacuum chamber. There it is. And when these experiments were done, obviously a paper was actually published, and it was immediately classified. And these studies have been done time and time again by various different people. Every time they're done, the papers are classified, and the results just simply disappear from the mainstream science record.
Brown entered the California Institute of Technology in 1922 and began establishing himself as a first-class lab man. His goal was to win over his professors so he could show them the results of his experiments and hopefully get them interested in the electrogravitic phenomenon. He had some of his equipment from his laboratory in Ohio shipped out to California, hoping to demonstrate the effects to his professors. He sent each of his professors invitations, invited them to come witness his experiment. Unfortunately, none of them showed up. Brown would later leave Caltech heartbroken and attend college back in Ohio at Denison University. In 1928, Brown published a paper on the Biefeld-Brown effect using the name of one of his professors, Dr. Alfred Biefeld. It is uncertain whether Dr. Biefeld had any actual influence on the experiments or on the production of the paper itself. These reported effects have been excused, ignored, and even ridiculed by mainstream science. According to Wikipedia, the Biefeld-Brown effect is a result of ion wind and not a gravitational effect. To support this statement, they cite vacuum chamber experiments carried out by the Mythbusters television show and another conducted by Dr. Martin Tajmar. They, however, fail to make any mention of conflicting experimental results. In 1955 and 1956, under the sponsorship of the French government, Thomas Townsend Brown conducted a series of vacuum chamber experiments at facilities made available by Société Nationale de Constructions Aéronautiques du Sud-Ouest, a Paris-based aeronautical corporation. There, Brown flew a pair of miniature saucer-shaped airfoils in a high vacuum of less than 1/1,000,000th of an atmosphere. According to alleged witness reports, not only did the discs propel themselves more efficiently inside of a vacuum, but they also sped faster since without ion leakage they could be energized with greater voltages. So despite what the science police who monitor Wikipedia have to say, the verdict on the Biefeld-Brown effect is not quite so cut and dry. Without further experimentation and analysis, it is impossible to tell whether this is an elaborate hoax on the part of Thomas Townsend Brown or a scientific cover-up of the electrogravitic technology. One thing is for certain, the government and military seem to be hiding something. In its March 9, 1992 issue of Aviation Week and Space Technology magazine, they made the surprising disclosure that the B-2 advanced technology bomber electrostatically charges its exhaust stream and the leading edges of its wing-like body. Although these disclosures were framed in the context of enhancing the B-2's radar and visibility, it is believed that they are in fact part of an electrogravitic drive capability. Aviation Week obtained this information from a small group of renegade West Coast scientists and engineers who were formerly associated with Black Research Projects, which are defense research projects that are so secret that even their very existence is classified. Northrop, the prime contractor for the B-2, had been experimenting with applying high-voltage charge to aircraft hulls since at least 1968, when at an aerospace sciences meeting held in New York in January of 1968, scientists from Northrop's NORAIR division reported that they were beginning wind tunnel studies on aerodynamic effects of applying high-voltage charges to the leading edges of high-speed aircraft bodies. Similar research was carried out in 1965 by the Grumman and Avco corporations. Interestingly, in 1994, Northrop bought out and merged with Grumman. Brown also called attention to this effect in his 1960 electrokinetic apparatus patent, which describes using a flame jet generator to place a high-voltage positive charge on a needle-like electrode at the front end of a rocket. Aerospace companies later put Brown's suggestions into use. A spike was placed on the nose of a rocket and caused to emit a high-voltage arc. Wind tunnel studies showed that the resulting electric field pushed the bow shock front away from the nose of the rocket so that it no longer contacted the main body of the missile, and hence substantially reduced the air drag. Now, there's a big difference between using high-voltage electrostatics to reduce air drag versus producing gravitational effects. If the presence of extremely large electric fields can affect local gravity, it could be the breakthrough that scientists and gravity researchers have been waiting for, or maybe they've just been ignoring it all along. Either way, the information I have just provided you with should be enough to warrant a further investigation. According to Dr. Eugene Podkletnov, high-voltage electrostatic fields produce a polarization of the vacuum energy density, or a polarization of the subatomic particles which constitute the vacuum, and thereby produce gravitational effects. There is also apparently more than one way to achieve this.
Magnets go a lot further, or electromagnetic or electrostatic force goes way further in explaining this idea of gravity than anything else, and it's not even that it has anything to do with gravity as we're taught it. Basically, the buoyancy and density argument works very well, but like I've said many times before, there is still something that determines up from down, and as I believe and many other physicists believe, not the least of which would be Wal Thornhill of the Thunderbolts project. That it is a static dipole effect that is essentially that potential of up from down is set by the natural electrostatic charge of the Earth plane itself. And, commensurate with that, if the Earth is indeed some sort of an electric circuit, then the anode, the cathode would be the Earth. And we know that the Earth has this static field, even by mainstream physics, that is measured at 100 volts per meter, going up to at least 50 kilometers, right? Which gives us a minimum static potential, or average, of 5 million volts.
Much of the following explanation is adapted from Nobel Prize-winning physicist Richard Feynman's lecture on physics, a section called Electricity in the Atmosphere. For every meter you go up in the air, the voltage increases by around 100 volts, or we could say around 100 volts per yard. We can draw these voltage increases using what are called equipotential lines. Notice that the ground is negative and the sky is positive with respect to each other. According to Feynman, this extends upward to 50 kilometers, or 31 miles, where the air is very conductive.
It goes up 50 kilometers, according to Richard Feynman, or 31 miles. And at 100 volts per meter, that leaves us with a static potential in the air between the Earth ground and 31 miles up of 5 million volts. Okay, that's not that's not a small figure. Believe me, 5 million volts is a lot of energy, a lot of voltage. Now, the thing about the static electricity is, even though it's extremely high in voltage, it's very, very low in current. So fortunately, when you're down at the lower levels and you go up on a tower and you're only experiencing a few thousand volts of that static electricity, because of the fact that the current is very low, it won't kill you. However, it does hurt, as I've said many times. So here we have Richard Feynman, which is talking about this electrostatic field which is emanating from the Earth, and essentially acting as a cathode. Now, if you have a cathode that must mean that you have some sort of an anode to complete the electrical circuit of the Earth. And of course, that anode would speculatively be the firmament, if you will, or if it's even physically up there. Otherwise, I'm not sure, because typically you have to have something to complete a circuit before you get any type of current flow. But the bottom line is that it is documented in mainstream physics by Richard Feynman that we have got this electrostatic potential, this fantastic electrostatic potential that's coming off the Earth to the tune of 5 million volts up. Well, so let's think about that for a second. What did Ken Wheeler just say?
Gravity is nothing other than dielectricity. Gravity is no different than turning on your TV set and actually shining a light off from the side, and you seeing the little dust particles actually head to the TV set and stick to the TV set. That's why you're running your TV set, especially little CRT tubes, got so dusty. The dust in the air would go gravitate to the front of the. That is the exact same thing as gravity. People think that that is an electrostatic charge, or like you charge a balloon up and you pull someone's hair to it. That same acceleration, not force, that same acceleration is what we ignorantly call gravity.
He said, well, if you've ever looked at an old CRT, your old television set, and you shine a light on it and you can see all these little dust particulates, being drawn towards this CRT, that is exactly what the effect of gravity is. And it's like, wow, that's what struck me as so strong, because we have that static electric potential off of the front of that CRT, which draws everything to it, and it doesn't seem to care what it is. And lo and behold, we have that exact same condition, except with a much, much higher static potential on the Earth itself, documented by mainstream physics and even broken down to 100 volts per meter. So what does that tell us? That tells us that, wow, it doesn't take a great leap of faith or logic to then see that what Wal Thornhill was talking about the static dipole effect, attracting everything to it, that it is indeed the Earth itself that sets the potential that determines up from down. And of course, any of you that have been following Globebusters for a while knows that my position on gravity has always been that, yes, I totally believe in the density and buoyancy argument. However, since day one, I have said there is still something that is determining up from down. Okay, and this is it. This is actually it. It's the static potential between the ground and the sky itself, proving unequivocally that gravity is an electrostatic force, which of course is all part of the electromagnetic circuit that we've talked about on Globebusters for several weeks here. It's so funny. You can have something right in front of your face and yet for some reason not see it. And Jaron, how many times have I talked about, me being up on a tower and getting the crap knocked out of me by static electricity? And it never occurred to me. It's like, oh my God, here it is. The entire Earth is the static thing. Now, obviously, as weather fronts move in and out, conductivity of atmosphere changes, that potential will rise and fall, and you will have dips in that potential when there is a static discharge of lightning, or you have sprites or elves that are discharging up and hitting something up there that would, likely be akin to a firmament. And again, this is something that, at least in the flat Earth model, with some sort of covering or dome, whether it's a dome or whether it's just a continuous plane of something, there is something up there that is giving us a charge potential between the Earth itself and whatever is up there, above us, a firmament or not. Okay, that at least makes sense in so many ways that where the ball Earth model just completely fails. So again, we can demonstrate this charge potential all day long. Static electricity, there's virtually nothing that it does not have an effect on. What he's doing is he's simply going to make the point that several things are electrostatically attracted, and it doesn't matter if they're metallic, it doesn't matter if they're wood, it doesn't matter if they're plastic. Electrostatic seems to have this exact same effect on everything. Here he's got a charged straw, and it's being attracted either way to his hand. Okay, so he's showing that. Then he's going to come up and he's going to put a straw in here again, and he's going to bring other objects in the vicinity of it. Now we've got a metallic object. I think he's got a fork there or a knife, something like that. And it's being attracted to it. So it doesn't matter if it's biological material like us, or dust, which would be dirt, or now he's going to use glass, or I think that's a plastic bottle, or maybe it's glass, I'm not sure. But he uses glass, and he uses all these different materials. Here we've got wood. Wood is attracted to it. So it's the electrostatic force, really, and even a thing of garlic salt, that he's making this point about, okay? So obviously the point here is that electrostatic energy can be very attractive, or it can be repulsive, but in our context in gravity, obviously we're using it as an attractive force. Now he also will take other objects, you know, like this knife, and he'll reverse it by taking the knife and putting it up there, and then he is, what's he doing here? Oh, then he's putting a plastic piece next to it, and we've got, again, this attractive force again. So long story short, electrostatics very definitely seems to attract everything. There's very few things, if any, really, that it doesn't have an effect on. It has an effect on wood, plastic, paper, biological material, everything. And why does it? Because everything is made up of these little charged particles, whether or not you want to accept that they are actually atomic structures, you know, with a nucleus being made of protons and neutrons and orbiting electrons, whether you want to look at it that way or not. The bottom line is that everything still has a charge, and it is this charge potential that is giving us our up from down in this model. After that potential is set, sets this framework, then the buoyancy and density argument takes over. And again, this is 100% demonstrable in a lab, whereas gravity is not. So really, who's got the better theory here, right? And not only that, when you look at what mainstream science has done with gravity, you know, we're taking this 9.8 meters per second squared gravitational constant that, you know, we are measuring on Earth as an acceleration, by the way, not a force, but an acceleration. And we are trying to apply it to everything that we're observing in the rest of the universe. Well, guess what? That doesn't work. Why doesn't it work? Well, because obviously we really don't know what these quote unquote gravitational parameters are out in the cosmos. And in fact, when you apply these same gravitational parameters that we're observing here on Earth to the rest of the cosmos, it doesn't work. So what do they have to do in that case? Well, then they have to invent dark matter, right? And all these other, you know, strange phenomenons that once again we can prove none of in order to bolster their theory. Where once again, you know, when it comes back to the simple electric universe model, and I mean in the flat electric universe model, not necessarily the one that the Thunderbolts promotes, which is far more accurate and far more plausible even than the mainstream heliocentric model. But when you get back to, you know, what we're describing about the Earth having a cathode and anode and a static charge in between it, and, you know, we can measure the static potential at 100 volts per meter on average all the way up, you know, at least we've got a demonstrable model, you know, in that particular area instead of a bunch of wild speculation, right?
Yeah. Density and buoyancy works, you know, to a degree to explain what goes up must come down. In normal cases, if you're discussing this with someone, they're going to tell you, well, you still need gravity in order for density and buoyancy to work. And that's not true. You merely need a tendency for higher density objects to naturally find a place at rest towards the ground. And yeah, I totally agree with you that it's the static electric charge of the Earth itself that gives it that nudge, and that's really all you need is a nudge. And I believe that's why they call gravity such a very weak force, because it doesn't really even in their model, it doesn't cause apples to fall from trees. That's really handed more towards the density and buoyancy as well. Gravity is merely that nudge for you know, where high density and low density objects find their place of rest naturally. Yes. And so, yeah, it really does. It really does explain it very well.
And the electrostatic force is a very weak force, right? The electrostatic attraction is very weak. We know that. You know, you can rub a balloon on your hair, and you can put it next to a water stream, and it will draw it over to it. But again, that's only in very close proximity. But in the grand scheme of things, electrostatic force is very, very weak. And again, that's the only thing that is required to tip the scales, so to speak, pardon the pun, in being able to give us what is actually up from down. And from that point forward, density and buoyancy absolutely explain everything. You know, from liquids, gases, everything follows this exact same parameters. And again, so even when you get into the idea, well, what about a hydrogen or helium balloon? Why does it float up? Well, look at the atomic structure of hydrogen and helium, right? And this goes back again into the dielectric theory that Walt Thornhill and many other physicists have proposed as being the actual cause of what we're perceiving as gravity. That makes so much more sense, and it's so much more demonstrable. It is demonstrable in a lab. Gravity is not, unless you're Neil deGrasse Tyson and you take a microphone and drop it on the floor and go, gravity, bitches. And that's about the best they can do. Sorry, not good enough.
Have you ever wondered what gravity is? Well, you certainly feel it when you run uphill like this. This is because of gravity. But what really is gravity? And in this video we're going to try to explain a simple electromagnetic understanding of gravity. Gravity is the net force on matter from diverging electric fields produced by motional magnetic fields in the orbital electrons of all normal matter. Well, what the heck does that mean? There are 4 key points to understanding how gravity is an electromagnetic effect. And I'm going to demo each of these 4 points in this video series. And the first point is the electric charge of a piece of matter is neutral because the positive and negative charges, the proton and the electrons, equally balance each other out because of the quantum nature of our reality. Number 2, the moving charges, which are mainly the electrons, negative charges, produce a Laplace force from the Lorentz equation, and they do not cancel each other out. And this is a big overlooked phenomena. So on a piece of neutral electric matter, the Laplace force does not cancel out because of the moving electron charges. And 3, the force from the Laplace force from moving electrons in matter is not shieldable. As you know, electrostatic fields are shieldable with a thin aluminum or a conductive sheet, but the Laplace force from moving electrons in matter is not shieldable. Number 4, major point about understanding gravity is that electric fields or diverging electric fields produce a suction on neutral matter, even though there's no charge on the matter at all. The matter will feel attracted or feel sucked towards the center of the diverging electric field. And today we are going to tackle and make a demonstration on just this point alone. First one is going to be doing it with a uniform homogeneous electric field, and the field lines are parallel, and we're going to put a test object somewhere in the middle of this to see if there are any forces. And the second type of test we're going to do today is the divergent electric field, and the field lines will be going out radially from a source, and then we're going to put a test object somewhere in the middle here of the radial field to see if any forces. We're going to dangle a test object in the uniform electric field, and we achieve that by having a parallel plate capacitor. One side of the capacitor is connected to earth ground. You do that by driving a pole into the ground and connecting it to the capacitor. And then the other side we have a high voltage source of about 15 kilovolts from a miniature Van de Graaff generator, and this will produce some pretty homogeneous field lines across the space between the plates of the capacitor. And we're going to head dangle a test object from a thread in the middle here and see if there are any physical forces on this test object. The first object to be tested here is a styrofoam peanut, and the charge is coming in from the right, and you can see that it twists but it doesn't move. Then we have an aluminum foil peanut, and it twists and pretty much stays the same spot. I don't have the thread on the exact center of the aluminum peanut, but it's good enough. Then we got a glass ball test, and it's a little heavier, but it does not move at all. Then we got a conductive ball test, and it does not move as well. And as you can see from the test results on the previous test, in a uniform electric field there is no net force. The objects do not move to the left or the right. There is only some twisting due to the polarization. And on the second series of tests here, we're going to produce a divergent electric field. We have the grounded side of the capacitor to earth ground as before, but on the other side we got actually a cylinder soda can which is connected to a 15 kilovolt miniature Van de Graaff generator, and this will produce some diverging electric field lines, and we dangle a test object somewhere in this area to see if there are any forces on the test object. And finally we have the divergent electric field test. The styrofoam pulls strongly towards the charged cylinder, and the aluminum foil peanut, it also pulls towards the charged cylinder, and the glass ball will pull towards the cylinder as well, and you can see the conductive ball will pull towards the cylinder as well. In a diverging electric field, there is a net force always, because the test object is not only polarized, but there is a difference in the negative and positive side of the object that pushes or draws the object towards the center of the field. So it's not zero. Force is not zero, it is something, and the object is drawn towards the denser region of the source of the field. And the field source could be positive or negative, doesn't matter. The object is still drawn towards the denser area. Nang Lee, a lady that was also trying to work with Dr. Podleknov, she had some promising results by rotating charged semiconductors in super cool conditions, and suddenly shortly after the year 2000, she took some money from the government and basically went underground to work on anti-gravity projects, and she was never heard from again, at least work-wise. She probably still has friends and family. Floyd Sweet was a researcher that in 1988 published a paper called Nothing is Something, and he had some barium ferrite magnets that he had conditioned in a special way where he could feed a very small AC current into the magnets through some ordinary copper coils, and was able to generate over unity effects. He even had his device running cooler than the environment, and even lost weight in one test that they did. Test that they did, and a lot of, not a lot, but a few researchers have tried to replicate his device and have not been successfully doing so. Although I did hear some rumor about one guy who was able to, I forget his name, was able to replicate his device, and the word is that he suddenly started appearing in expensive clothing and expensive cars, and from what I hear was living very well, which seemed to have come across some money. So the question that people were asking is perhaps he sold out his technology, his replication of the Floyd Sweet device to somebody. We don't know who or if it really happened, but that's the word on the street, that he sold out. But the Floyd Sweet device actually resonates very well with me, and the electrogravity theories that I developed back in 1987, because it's using what's called the B cross V field effect, which is a Laplace force. That's the magnetic force effect in the Lorentz force equation. It's not a pure electric effect, but it's the magnetic effect from the Lorentz force equation. And I like to call it the Laplace force, or the B cross V field effect. The best way to generate strong B cross V field effects, which is the important ingredient for generating electrogravity, is to rotate charges as fast as possible, and that's what the Russian Searle device was doing. So it wouldn't surprise me if those results that were reported were in fact real. That wouldn't surprise me at all. But it's sad that technology was not continued to work. From what I heard on the street was that the device was destroyed or it was stolen, and they ran out of money, and the usual stories about how the inventors couldn't continue the work because they lacked money.
That's what I do. I'm Neil deGrasse Tyson, bitch.